Hello everyone, welcome back to our GRE Mastery Series. I'm Eli Andy, a GRE instructor here at the International Scholars Program. Today we'll be looking at properties of triangles. So let's begin. We have the first property here that is relatively well known, but we'll start with it and build on from there. So this first property says that the sum of all internal angles of a triangle will always sum up to 180 degrees. So if you have a triangle like this, so let's just sketch a generic triangle because this property applies to all triangles. So if you have the angles X, Y, and Z, then what this property is saying that X plus Y plus Z sum up to 180 degrees. Let's look at the second property, that the length of any side of a triangle will always be less than the sum of the other two sides, but greater than their difference. So again, with our generic triangle sketch, this time we'll be focusing on the sides. So let's give them A, B, and C. So according to this property, if we pick a side, say A, its length will be less than the sum of the other two. So in this case, it will be less than B plus C. And at the same time, that same side A will be greater than the difference of the other two sides. And we can combine this to say that any side in our example A ranges from the difference of the other two sides to the sum of those same two sides. For property 3, we have that the side opposite to the largest angle of a triangle is the largest side. Also, we can say that the side opposite smallest angle is shortest side. So let's see this in our sketch. This time we'll have both angles and sides. So we have the angles X, Y, and Z, and the sides A, B, and C. So according to this property, if A is the longest side, then the angle opposite it, which in this case is Z, is the biggest angle. Similarly, if suppose C is the shortest side, then the angle opposite it, which in this case is Y, will be the smallest angle. We can combine all this in this representation. We can say that if A is less than B, which is less than C, then the same relationship will hold for the angles. That we can say then the angle opposite A, that is Z, will be the angle opposite B, that is X, will be less than the angle opposite B, that is X, which is also be less than the angle opposite C, which is Y. So for example, if we have a triangle of sides, let's say we have 3, 4, 5, then so let's say we have the sides 3, 4, and 5, and we have the angles, let's say we have the angles 40, 50, and 90. Then we'll have 40 here, then 50, 40 will be here, then we'll have 50 here, and 90 here. Okay, let's look at the fourth property, that any exterior angle of a triangle is equal to the sum of its interior opposite angles. So let's sketch and see what we mean with by exterior angle. So if you extend a side, then the angle it forms with the adjacent side is called the exterior angle. So in this case, let's call it angle E. So what this property means is that if we have the internal angles as X, Y, and Z, and the exterior angle E, then E will be equal to the sum of the interior opposite angles, in this case, X plus Y. So maybe for another illustration, suppose we extend this and get our exterior angle F here, then angle F will be equal to the sum of X and Z. So this applies for all exterior angles. Then for property 5, we have that for a given perimeter, equilateral triangle has the largest area. That is, if you have several triangles, that is triangles of different shapes, but same perimeter, and if an equilateral triangle is one of them, then that equilateral triangle will have the largest area. So for example, let's say we have a right angle triangle with perimeter 12, an isosceles triangle with a perimeter 12, and an equilateral triangle with perimeter also 12. It is this equilateral triangle that will have the largest area. Okay, let's move on to property 6, that for a given area, equilateral triangle has the smallest perimeter. So in this case, the area is common, so can again illustrate. Say we have an isosceles triangle with the area, say 20, an equilateral triangle with the area also 20, and a right angle triangle with the area also 20, then this equilateral triangle will have the smallest perimeter. Okay, moving on. So for this property, we have that with an equilateral triangle, the radius of the incircle is exactly half the radius of the circumcircle. So again, a sketch is always best for illustration. So let's say we have this. Don't mind my sketching skills. Illustration is what matters here. So this is the circumcircle. Then we also have the incircle. So let's give this center O. So what we are saying here is that OA if A is this, meaning OA is the radius of this in circle, OA will be a half the radius of the circumcircle. So calling it OB, it will be half the radius of OB. Remember, this property only applies for equilateral triangles. Okay, then let's look at a few bonus properties for right-angled triangles. We'll be looking at two right-angled triangles. They are unique properties that other triangles don't share. So we'll start with the 45, 90 triangle. This is an isosceles right-angled triangle. With base and height equal, and here 45, 45. So for this, what we need to know for the purposes of the GRE is that the ratio of the sides will be 1 to 1 to root 2. Or you can say x to x to x root 2. So for example, if this side, the x to x, these are of course the equal sides, the height and the base. So if we have 4 here, then we'll have also 4 here, then the hypotenuse will be 4 times root 2, right? Then let's look at the other right angle triangle, that is the 30, 60, 90 triangle. So again, a sketch. So let's say we have the 30 here and the 60 here. So for this, the ratio of the sides will be 1 to root 3 to 2. Or you can say x to x root 3 to 2x. So for this one, let's say if this side is 4, just as an example, what do you think the other two sides will be? Take a moment to guess, or rather to calculate, right? So going by our previous property that the side opposite the smallest angle is also the shortest, then it makes sense that our x, which is the smallest in this ratio, will be 4. So if you got the side opposite 60 as 4 root 3, then you are right. And then the hypotenuse as 2 times 4, that is 8, then you are also right.
You are watching Success with Bob Mwiti Show, presented to you by the Kenya Airlift Program. The Kenya Airlift Program is an award-winning education financing scheme that helps bright Kenyan students to pursue graduate studies in North America, regardless of their financial background. You can find our programs by going to www.kenyaairliftprogram.com. The Kenya Airlift Program, empowering dreams.
So those are the properties we were to look into today. Of course, the list is not exhaustive, but those are some of the most common you'll meet in the GRE. So let's look at a few examples to see how these properties are tested in the GRE. So here is our first example. So this is a quantitative comparison question. We have a triangle here, 10, 10, meaning this and this are equal. So we can apply two properties here to figure out whether to figure out the relationship between quantity A and quantity B. For example, we say that the sum of all angles, interior angles of a triangle is 180. So if we have here X and Y, then 40 plus X plus Y will give you 180 degrees. And because we have X and Y the same, because base angles for an isosceles triangle are this equal, then we'll have 40 degrees. We can have X plus X being 180, so that 2X will be 180 minus 40, which is 140, and X will be 70 degrees. So X will be 70, Y will also be 70. Then recall the property that the side opposite the smallest angle is the shortest side, and also the side opposite the biggest angle is the longest. So in this case, the side opposite 40 will be less than the side opposite 70, right? So AB, which is what we want, is opposite 40. So it will be shorter than the side opposite 70. So in this case, AB will be less than 10, or you can say quantity B is greater. Let's look at another example. So again, we have a quantitative comparison question. Here we are told that the triangle ABC is isosceles and the base is AC. So if the base is AC, it means AB and BC are equal. And it also means that this angle C is also 51. So for angle B will be 180 minus 2 into 51, 180 minus 102, which is 78 degrees. Okay, so the question is asking for AB over AC compared to 1. Now, from this, you can see that side AC will be the longest. Yes, AC, longest. Then AB, which is equal to BC are the shorter sides. So if you have a small number divided by a big number, the result will definitely be less than 1. For example, if we have 2 over 10, the result is a fifth, or 0.2. So whatever the measurement for these sides are, because AB is less than AC, quantity B will be greater than quantity A. Another example, in this case, we have a triangle ABC. So again, we'll sketch it. A, B, C. And this time we are only told that AC has a length of 12 and AB has a length of 5. So we need to know whether we need to know the relationship between side BC and 13, this side. Now here we'll use this property that a side, in this case BC, of a triangle must be less than the sum of the other two, in this case 5 and 12, but greater than their difference. So our BC will be greater than 7, but less than 17. Now from this, length BC can be shorter or greater than 13, because for example, if BC is 9, which is greater than 7 but less than 17, then B is greater than A. But if BC is 15, which is also greater than 7 but less than 17, then A is greater than B. So when you have such a contradiction in quantitative comparison questions, then the result is that the relationship cannot be determined from the information given. Okay, so we'll look at our another example here. So in this case, we have an isosceles triangle PQR. So let's sketch this. P, Q, R, and we are told that P is 80. So it can be tempting to do this question like this, have 80, and then 50, 50, and then conclude that angle R is 50. That would be only partially correct, because all we know is that P is 80, but we don't know whether P is a base angle or not. So for example, we can have this same triangle sketched in this manner. We can have P, Q, R, but then have 80 here, 80, and then 20. In this case, R will be 20 degrees. In this first instance, R is 50. So R can also be 20. But then again, we can still sketch the same triangle as P, Q, R. So we can have $80, 80 degrees, and 20 degrees. So R can also be 80 degrees, meaning 20, 50, 80 degrees can all be measures of angle R. So always consider every scenario. Then our last example, also another quantitative comparison question. We have two right angle triangles. So as you can see, the first triangle here is the 45, 45, 90. And here we have the 30, 60, 90 triangle. So we want to compare the area of ABC with the area of the first triangle with the area of the second. So remember the property giving us the ratio of the sides for this special right angle triangle. For this one, the ratio is X to X to X root 2. And for this one, it is X to X root 3 to 2X. So if we have the hypotenuse as 2, and the hypotenuse corresponds to this last point, that is X root 2. So let's see for triangle ABC. For ABC, if X root 2 is 2, then X will be root 2. So we have both the base and the height as root 2. So the area will be a half times root 2 times root 2, which is a half times 2, which is 1. So quantity A is 1. Then for the second triangle, we have the hypotenuse as 2. So 2x is 2, meaning x is 1. So we'll have here 1, because it's the shortest side opposite 30. Don't forget about that. Then we'll have the side opposite 60 as x root 3, which is root 3. So for this one, the area will be a half times 1 times root 3, which should be root 3. Sorry, this should be root 3 over 2. And root 3 is approximately 1.7 something divided by 2. It will definitely be less than 1. So quantity B is less than 1. So the conclusion is that quantity A is greater than quantity B. So these are some of the ways that triangle properties are tested in the GRE. I hope you have learned something and you can build on from what you have learned here in further practice. So bye and welcome back next time.